Hello and welcome, this is question 4 for Edexcel's M1 June 2003 past paper. Okay, so in this question we're given that there is a mass M1 for 5 kilograms on a slope which is being held by a 20 Newton force. Okay, so that it's in equilibrium just, and we've got this angle alpha, okay, and we're told that tan alpha is 3/4, okay? So therefore, obviously you could work out that the alpha is equal to the tan inverse or arctan in the old way of 3/4, which obviously should get you alpha to be 0.64 radians, okay? It doesn't matter which way around you use it, you'll end up getting the same answer that they want you to get. Okay, so what we need to do is resolve. Okay, so we can't just go ahead and calculate this 20. What we want, shut up. What we want to do is calculate the coefficient of friction, or in other words, mu. Okay, and we do that by using well, obviously, if what we normally use for something like this is F equals ma. Okay, and apply that situation to this. Okay, but we can't the A, because it's in equilibrium. Obviously, it's not moving. Obviously, definitely not accelerating. So therefore, A equals 0. So our resultant force equals 0. But we've still got an equation for the resultant force, okay? And making that equal to 0 will give us, will enable us to find out the coefficient of friction, okay? Which is obviously this friction along the plane. Now, what we need to do, what we normally do in this, okay, is like, well, there's mg sine theta, I put it down here, and F equals ur operating up this way. But because this 20 Newton force is acting, it's acting at an angle, and the angle it's acting at is by, well, we can work it out using alternate angles, okay? So when we draw this line here, this therefore angle must also be alpha, okay? That's just something you should be able to work out from alternate angles, even though it doesn't look quite like an alternate angle. If you carried that on and used this angle here, which is obviously the same as this one, therefore you would get alpha. As I said, hopefully that made some kind of sense. Anyway, so therefore these two values are exactly the same. And that's kind of the key bit to understanding this question. Alright? And what we need to do is turn this into its horizontal and vertical components. Now, even if you weren't able to understand that, you would have hopefully understood that we needed to split the 20 newtons up to its horizontal and vertical components, okay? Now, obviously we know the mass of this M1 is 5 kilograms, so the first thing you might want to draw is the weight, which acts vertically downwards, even though that isn't vertically downwards, which is mg, okay? So it's just, in other words, 5 times 9.8, or it's written in the mark scheme 5g, okay? Which I think is a little bit confusing, but hey ho. Okay, and then the normal reaction force actually into the plane, we always call that mg cos theta, okay? But we're going to be adding something else to that in a minute, because this, obviously, this resultant force, this is the resultant, we have a horizontal and vertical component, and the horizontal component of this 20 Newton force is going to add to our horizontal reaction force of this mass, okay? So, to work out the horizontal force of this, so the vertical component is 20 newtons, what we do is we do 20 newtons times the sine of alpha, okay? So it's 20 newtons times the sine of alpha, so 20 newton sine alpha. But we also add the mg cos theta to that as well, because we need to stop it falling into the mass or taking off, okay? So that's mg cos theta, or cos alpha, sorry. And obviously when to make them equal to each other, we add 20 newtons sine theta to this, or sine alpha. I keep referring to it as theta because it sounds better. Okay, so normally what we'd have coming down here is now we've worked out the vertical component is 20 newtons, we need to work out the horizontal component. But which way is this horizontal component of this 20 newtons acting? Well, it's pushing it up the slope, so therefore the horizontal component must also be pushing it up the slope, so our horizontal component acts this way. Okay, so our horizontal component of the 20 newtons, well, you calculate it, use cos, okay, because we've got, we've cos because we've got an adjacent and a hypotenuse, so it's 20 newtons cos alpha. Okay, so that's all the non-obvious ones now. So what we now need to do is work out the obvious ones, okay, because they still exist. Now, going down the slope, parallel to the slope, we have your mg sine alpha. Okay? And up the slope, we still have F equals UR, but we add that to this 20 newtons cos alpha, because the horizontal component of this and the F equals UR are acting in the same way. Okay, so we just use this information now to work out the resultant force being equal to 0, so that we can simplify it down to get the answer for the coefficient of friction. Now we know the two vertical forces are going to be balanced, but you've got to remember this vertical force is what we label as R in F equals UR. Okay, so that's why I drew it on there. Okay, so what we do now is mg sine theta, sine alpha, doesn't matter which round you put them for this case. Okay, take these two combined forces, so you do 20 newtons cos alpha. Okay, I'm going to sub in alpha and mg in a minute. Plus mu times r. Now we wouldn't expand this, I just mu brackets 20 newtons sine alpha. There's no need to expand it. Plus mg cos alpha. Okay, because all it's going to do is make it a bit more confusing for you. You don't need that. Okay, so that is equal to 0. Okay, so what you do now is sub in what you know. Okay, well you know obviously m is 5 and g is 9.8. Okay, so it's 5 kilograms times 9.8 times the sine. As I said, you could do it in degrees if you want, but I've done it in radians, so I've got 0.64. Okay, so you square bracket that off, take square bracket this off as well. So take 20 newtons cos 0.64 radians, and if you use radians for all of it, or degrees for all of it, you should get the same answer. Okay, it shouldn't make a difference. Plus mg, which is 5 kilograms, times 9.81, sorry, times 9.8, times cos of 0.64 radians. Okay, so square bracket that off as well, and that equals 0, so you carry on this line, you work out what 5 kilograms times 9.8 times the sine of 0.64 radians, which is 29.4, okay, so 29.4. You take that away from, so you take away from that, which you do 20 newtons cos 0.64, which just gets you 16, okay, plus mu. Oh, I do apologise, made a bit of an error here. Set myself up, okay. So 20 cos alpha plus mu, I do apologise, 20 newtons sine 0.64 plus 5 kilograms times 9.8 times cos 0.64. I thought that was a bit short. I do apologise, but you know, you should have shouted out over the, because not only time travel your sound, but also put your hand up as well. So, okay, so anyway, that's 16. So we work out what mu is times by, which is 20 newtons sine 0.64 plus 5 kilograms times 9.8 times cos of 0.64, which you bundle all that together, you should get mu times 51.2. Okay, and that equals 0. So it's a case of simplifying it down. So 29.4 take 16 should get you 13.4. Okay, so 13.4 take 51.2 times mu equals 0. So see, therefore 13.4 equals 51.2 mu. Divide both sides by 51.2. So mu is equal to 13.4 over 51.2. Okay, and that is your coefficient of friction, which should give you 0.26. Okay, which is your answer. Okay, so a lot of working out there, but as I said, it was really just a case of being able to understand it. Now, mechanics Edexcel, love these kind of plane questions. Okay, incline plane questions. There's another one coming up later on in this paper, but really that is quite a difficult one. The next one that's coming up isn't too bad, although it's still got a little bit of a compelling factor to it. But for question 4, that is again quite a difficult one. Okay, so thanks for watching. Okay, it's quite similar. If you want to get enough practice on these kind of resolving plane questions, please do check out the June 2015 paper. I think it's question 8, where there's a question that's very similar to this, except the fact that we have two masses on connected with a frictionless pulley, which is obviously taking this up to another level, but we still have to resolve some kind of angles which are vaguely similar to this. So if you want some more practice on that, please do check out that paper. Okay, so thanks for watching, and we'll see you in question 5.